ISHRI, Indian Society of Heating, Refrigerating and Air Conditioning Engineers. Founded in 1981 at New Delhi by a group of eminent HVAC and R professionals, ISHRI now has a total of 41 chapters and sub-chapters.
ISHRI gives you the latest industry insights of the HVAC and R and building industry and delivers latest technologies in forms of technical blogs, videos, and articles to people. It has more than 14,000 members and about more than 10,000 student members. ISHRI releases various standards for HVAC and R building industry time to time. It organizes more than 800 events every year, including seminars, conferences, product presentation and more. ISHRI also provides handbooks and guidelines. ISHRI also has student chapters in more than 150 engineering colleges, to encourage students, and let them know about HVAC and our industry. Visit now, ishri.in, for more details.
Is it clear screen, Ravi?
Yes, sir, your screen is visible.
Yeah, so welcome all of you for this refrigeration applications for using natural refrigerants, the webinar series conducted by ISHRI. Today is this session 7th, 14th of August, how to build safe ammonia plant. Speaker, Mr. Ramesh P. Paranjpe, who has the MTech from in refrigeration from IIT Mumbai, a fellow life member of ASHRAE. I would like to welcome our speaker, Mr. Ramesh P. Paranjpe, and also I would like to thank our speaker for having conducted all these sessions 1, 2, 3, 4, 5, and 6. And also I would like to thank all the participants. We had more than 350 for each session, and it's very encouraging. We have got all your feedbacks, and we have got your questionnaires. We have responded back to your questions. The presentations have been made, the soft copies, and it's also available in the website, which I will tell you shortly now. Okay, an introduction to our speaker, Sri Ramesh Paranjpe. He's the fellow life member of ASHRAE. Our distinguished 50-year service award from ASHRAE in 2020. He has been awarded this award. Member of ASHRAE Fundamentals 2017 Volume Committee. Fundamentals is one of the 5 volumes of ASHRAE, and he's the member, he's the author and member for the Fundamentals edition in 2017. He's a member of IAR USA, and he has an MTech from IIT Mumbai. Professional experience, 6 years as the Chief Executive Officer, Voltas International Limited, Pune. 4.5 years Managing Director, Carrier Refrigeration Limited, Bangalore and Singapore. And prior to that, 27 years and was the Vice President, ACR and R Division at Kirloskar Pneumatics, Pune. Our speaker, Mr. Ramesh Paranjpe, was the examiner and also paper setter for the University of Pune for Master of Engineering and also in the syllabus formulating committee. He has published more than 45 papers in international and national journals. Has conducted more than 300 training programs at Honeywell, Alpha Level, Voltas, Blue Star, Thermax, Emerson, Tata Motors, LG, ISHRAE and ASHRAE forums, and on international levels in US, Singapore, China, and Germany. And he has met the ASHRAE objectives in sharing knowledge and information through publishing papers and conducting training programs, as well as promoting the arts and science of refrigeration and air conditioning, for which he has been recognized for this award from ASHRAE. The other achievements are he was invited by the German Chamber of Commerce to deliver the lecture in Germany on ammonia pump circulation systems for low temperature applications, presented a paper at IIR conference in Macedonia on energy saving techniques in ammonia pump circulation systems, the winner of the Bry Air Systems Design Award, winner of the Lifetime Engineering ICE Danfoss Global Chain Award, published a book on cold room solutions for immersion uh, climate, then published a book for Danfoss on controls, how to use ammonia, making it easy and safe to be efficient. It's for Danfoss Controls. Then published a book on air cooler design for cold storage for Alpha Level in the year 2015. He has executed more than 700 projects for cold storages, including the ice cream industry, process plants, fish and meat freezing, as well as air conditioning, such as international airports, office buildings, shopping malls. Our speaker can be contacted. His contact details are there, email and the website. And if you go to this website, you can see all the presentations of Sri Paranjpai he has uploaded for the benefit of each and everyone. So now I would like to invite Sri Paranjpai to take up the today's session.
Okay. You can see my screen now.
Yes,
Hello?
sir, we can see your screen.
Yeah. No,
You
I
need
have
to put
made,
slide mode.
yeah, I made it larger now, and
Yes.
I will start my presentation. If you can hear me, okay. I'm going ahead. Is it clear now? Okay.
Yes, sir.
Okay.
Yes, sir. Your voice is clear.
Okay.
We can hear you.
Now, first of all, let me thank ISHRE and all the team of ISHRE who has taken trouble to spare their time in giving me this opportunity to share my knowledge and information. In last 6 sessions, we covered mostly all good points about ammonia. In the second session, we did discuss some drawbacks of ammonia, but still, if you see general perception of the people, ammonia is still earning a bad name because of the accidents and ammonia leaks which take place. So today I'm going to discuss how to build a safe ammonia system and what precautions need to be taken to overcome the drawbacks of the ammonia system. With this we will start. We will take a break in between because ref cold is a very important event and we want to show some information or video on ref code. So we'll maybe after 1 hour or I will guide the conveners that yes, now we can take a break. Okay, with this we start and this is the first slide. Today's subject is how to build safe ammonia plants. Now the most important aspect of it is the attitude of a person is very important. It is the responsibility of not xyz person, it is the everybody's responsibility. Attitude, as you know, if you allot a letter A as 1 mark, 1 count and grade as 26, attitude adds to 100, whereas all other combinations, whether experience, knowledge, all they don't add to 100. So attitude is very important. Next thing is, lot of people call me and they say, okay, all your plants are, we haven't heard any accidents so far. Can you make our plants safe? So it is very important to understand that safety is not something which is an accessory which can be added later on. Safety is built into a plant design, right from perception to installation and commissioning and maintenance. All these aspects have to be taken care very, very carefully to ensure the safety of the plant. Hello. Well, you can hear me, no? Oh, okay. Hmm. So why safety standard is important? Because for ammonia, why it is so important? Because majority of ammonia systems are field erected. If it is food processing plant, then blast freezers, plate freezers, IQFs, all are located far off in a processing hall, and these are away from the machine room. They are installed individually, and the proper piping is done to be interconnected. Same is applying to industrial process plants. The plant can be as away as 1 kilometer from the process area. Currently, there is no restriction in India as who should construct a cold storage or ice plant or any other plant, who should erect it, leading to incorrect selection as well as incorrect installation, especially as regards the piping and insulation is concerned. We take a lot of care in selecting the proper equipment like compressors, condensers, receivers, or motors. But when it comes to erection, then people try to give it to someone who is known to them and who doesn't have much expertise on ammonia plants. And this is one of the major reasons why the accidents or malfunctioning of the takes place. This leads to malfunctioning of the plant, leakages and accidents. And accidents are dangerous due to toxicity of ammonia. Ammonia, as we discussed in our second session, it is toxic and little bit above a particular percentage flammable. But we also discussed that flammability is not an issue because ignition temperature is very high, 650 degrees centigrade. So toxicity, leakage of ammonia is the main issue. And we are going to discuss today how to build a plant which will not leak. One should not, when you go to the machine room or a plant room, you should be wondering whether this plant is with ammonia or some other refrigerant. So AR, therefore, our Association of Ammonia Refrigeration has published guidelines and suggestions on installation, operation, maintenance of a field erected ammonia plant. I would suggest ISRE. It is available to everyone. You can buy it from AR, but it gives, for example, these days, because of my age, I don't go to site, but I tell the erection engineer, take this book and tick mark and send me a mail from your boss that you have covered all the points which I have mentioned in my book, and then there is no need for my coming to site. You can commission it, nothing will happen. For example, uh, Gadre Marine Mangalore plant, which has 21 reciprocating compressors, a lot of freezers, plate freezers, and chilled water plants, etc. They have commissioned last year, but I haven't visited it yet. So it is very important that the guidelines should be followed properly. Now, looking at our book, BIS, Bureau of Engineering, Indian Engineering, is publishing ammonia standard, and we are helping them. Once this standard is out, I'm sure the quality of uh, systems built with ammonia will definitely improve, and unnecessarily the bad name which we are ammonia industry is getting will be removed. because then it will become a mandatory standard when government imposes it. This is the standard, safety standard of ammonia design and installation. This is written by me and it is published by AAR. It is available at a very low price, I think some 200, 300 rupees. So anyone can buy it from AAR. The next slide, importance of safety. Why ammonia is importance is safety? Because ammonia is a toxic gas and if released to atmosphere in an occupied area can cause harmful effects to workers and public. The risk increases especially when ammonia is under pressure. And in our refrigeration systems, normally ammonia is under pressure. Now, the next point is very, very important. Most of the people don't realize it. Liquid ammonia leaking is more dangerous than vapor. Since as liquid when exposed to atmosphere condition tries to convert into a gas because the boiling point of ammonia is -33. So any temperature higher than that, if it is exposed, it will get converted, liquid will get converted into gas. And the density of liquid is very, very and gas density is very, very low, with the result that when liquid gets converted into gas, it forms a big cloud, and people coming in contact with this leakages can get affected very adversely. So liquid leaking is more dangerous. My suggestion is never pour water on the liquid. Always wipe it out with a cloth after you put all other precautions like gloves, goggles, etc., etc. But never spray water on the liquid. This is very, very important suggestion. Now, just to give you a suggestion, look at this. Ammonia liquid leaks, the density is very high, 500 odd this thing. Ammonia vapor is only 12 kg per meter cube. So liquid density is 48.22 times more. So liquid ammonia leaks are more dangerous than vapor. Never spray water on ammonia liquid. Wipe it out with a cloth. This is an important suggestion which I am giving, and it is very important. Now, why ammonia refrigeration safety? Because we saw the toxicity of ammonia if you are exposed to it above 100 ppm for a long duration is dangerous. Up to 400 ppm short duration, nothing will happen, but subsequently it can create serious problems. Especially liquid falling on the person can lead to total burnout of the skin. I have seen a lot of potato cold storages who use bunker coils, and bunker coils are on the top. And if the bunker coil starts leaking, the liquid ammonia falls on a person, and there could be deaths, there could be serious injuries because the entire skin will be burnt and your bones will be exposed. So, liquid is very, very dangerous. Now, flammability, yes, is an issue, but above 60%, 16% concentration and ignition point, as I mentioned, it's 650 degrees centigrade. So it's not in reality a big issue. No, I had shown in my ammonia presentation that no ammonia equipment requires flame-proof equipment. A standard equipment is good enough. Possibilities now, where ammonia possibility leak exists. So we are going to talk about only toxicity issue, not flammability issue. And toxicity will take place only when ammonia leaks. Now, which are the areas where ammonia could leak? It could be vessels, accumulators, receivers, LP vessels. Major are flange joints. So try to avoid flange joints preferably. Use all welded joints. Then stop valve glands. If you don't lubricate the stop valve glands and if they become dry, there could be a leakage of ammonia from the glands of the stop valves. Pressure relief valves, if they are leaking, there could be ammonia leaks. During charging, refrigerant charging, using wrong pipe, incorrect method of charging can lead to big ammonia leakages. Manually operated valves, like especially oil drain, as we have discussed earlier, ammonia and oil is immiscible. And if you don't use a good oil separator, the oil will be everywhere in the system, receiver, LP vessel, oil pot, drain, coil drain, and you need to drain the oil everywhere because oil does not give any cooling and it can affect your cooling performance. So during oil draining, there is a chance of ammonia leak quite a lot. Then shaft seals, compressors, pump sets, as we discussed, the copper motors are used as an external drive, and therefore the shaft seals, there is a possibility of leak. There are no hermetic compressors so far being used for compressors, although we discussed in our one of the sessions the latest developments of hermetic and enclosed motors for ammonia compressors in scroll compressors, semi-hermetic compressors, etc. The possibility of leak also exists from side glasses. If the side glass breaks or if they do not have the non-return valves at the inlet and outlet, there would be, when side glass breaks, if it doesn't close the main receiver outlet lines, there would be heavy leakages. So these are the areas where ammonia leaks. And if you, this is a global survey which has been done. This is not prepared by me. This is prepared by IIR, International Institute of Ammonia Refrigeration, and they have analyzed all the accidents and leakages, and flange and joints, 23% leakage, manual control stop valves, 20%, pumps, 12%, pumps, compressors, etc. Compressors around 9%, pressure relief valves leaking, 9%, oil drain pots, 8%, piping leaking, 7%, during charging, 5%, evaporators, 4%, and side glasses accidents taking place, 2%. So these are the various areas which can lead to a leakage. Now let us discuss which are the possibilities. Who can, as we discussed, it is an attitude. Attitude is important right from the designer up to the operator. And let us say general design deficiencies of the plant which can happen. That is a designer's problem. Omission of an important component like standby receiver. I will tell you one accident when a person was trying to open the valve in the liquid line for starting. The whole coupling, which is welded to the receiver at the bottom, came off because the welding was not properly done. And with the result that nothing could be done, there was no standby equipment available till the entire ammonia leaked from the receiver. My God, it was a horrible thing. People had to suffer a lot. So very, very important. We need to do proper welding, have a standby so that we can always pump down in case one receiver starts leaking. Then failure to follow good engineering practices, correct standards, failure to follow manufacturer's installation instructions, failure to comply with requirement codes and standards, failure to provide proper piping design. Now this is the piping diagrams design, only PNID is not good enough. you need to give 3D drawings, how the piping routing should be done. That is very, very important. Failure to use proper type of controls, using incorrect controls also can cause problems. Failure to use correct material and practices. Failure to recognize changes needed when the plant is adding new equipment. A lot of people do expansion, and then while doing expansion, there is a problem. Failure to provide proper removal of oil, air, and water from the system. All these three things. So these are all designers' deficiencies. Now we go to contractors' fault. What a contractor, erection contractor can do. Failure to install piping according to the piping practices. These are, as I told you, have been clearly defined in our AAR book, and you can have, I have given the diagrams also in that, how to route the piping in our latest edition. Failure to provide convenient access to atoms needing adjustments like expansion valves. Now, expansion valves for air coolers may be at 20-meter height, and if you don't have a ladder or a platform to reach that expansion valve, and if the temperature inside the room is minus 20 degrees, no operator will go there, and there could be a problem of attending that valves. So this is very, very important that a space should be provided, access should be provided to all the controls which need adjustments. Failure to provide adequate instructions to operator at the startup. One must be able to train the operator on this particular plant. Every plant is different. Every plant has some specialty, and he should be trained before he is asked to go and commission the plant. Startup supervisor has little knowledge of the system functioning of the components. That is not acceptable. Normally, those are administrative people, and they are just plant managers, but they do not know much about refrigeration air conditioning. I have seen this in many, many plants. They say that is the responsibility of the operator. It is not so. It is the responsibility of everyone. Failure to recognize or bring to owner's attention code violations. The operators are many times afraid to complain to his boss that, sir, what you are telling is incorrect. Actually, it should be done like this. But they are afraid of it. Making unauthorized changes or additions to the system. This happens on the contractors when the expansion is taking place. So this is very important. I have seen many places, operators, there is a boss-like relation that मालिक एक है, प्लांट रूम का मैनेजर एक है, इंस्टॉलर एक है, और ऑपरेटर एक है, as a ladder structure, and everyone is afraid of the next level to share the problems, and this leads to major accidents normally. Now, operator fault may not be qualified for routine responsibility. Many times the owner says, अरे ये मेरा छोकरा है, उसको कुछ काम नहीं है, उसको मैं ऑपरेशन प्लांट रूम का ऑपरेशन बता देता हूँ. Yeah, it can be done, but he has to be trained thoroughly and he has to be qualified as a routine responsibility. So he may not completely understand the design according to which the system is intended to operate. May not realize when the equipment is not functioning properly because he doesn't understand which is high discharge pressure, what is the high discharge temperature, where the oil should be, etc., etc. May not understand and analyze correctly as to the causes which causes system problems. May not be aware of the consequences which could result from improper operation. Lot of people, operator I have seen, वो मोटर ओवरलोड होता है तो वो लिक्विड लाइन बंद कर देते हैं, बोलते हैं नहीं नहीं लिक्विड का सप्लाई कम कर दिया तो मोटर ओवरलोड नहीं होता है. बट दैट लीड्स टू लो सक्शन ऑफ द compressor, high discharge temperature, and your compressor can break. So there are many issues. Operators just don't do it without understanding what could be the consequences of his not operating the plant properly. May not bring to the knowledge of supervisor or management about abnormal working. Oh, he is afraid. He says, "Abhi my boss ko batayega, so he will tell what you were doing all along. It is your responsibility." So this is incorrect. There should be a very good relationship between owner, and every week probably they should get together and discuss what are the issues with our plant and take the advantage of the operator fully. He may not be qualified, but he is managing your plant, so he has more knowledge about the system. So may have many misconceptions that lot of people I have seen, especially on ammonia plants. 99% people close the suction and discharge valves when they stop the plant and open the compressor suction. I said, why are you closing and opening the valves? जैसे नहीं ये स्टैंडर्ड प्रैक्टिस रहता है अमोनिया प्लांट में कंप्रेसर का वाल्व हम बंद नहीं करते. I said, what is the reason? Do you do it in Freon plant? When Freon plant closes, do you shut off all the valves? जैसे नहीं उसमें नहीं लगता है, अमोनिया में लगता है. अमोनिया में क्यों लगता है? There is no answer. Now we have installed plants with 23, 24 compressors in a machine room, and you cannot close all the valves when the plant stops working. So valves should never be touched unless you want to remove the compressor from the system. Nothing happens. Why people do that? Because they undersize the condensers and motors. If you do that, yes, then gradually you have to open the suction valve so that your motor is not overloaded or condenser is properly loaded. But if you design the plant properly, if the designer has taken care of sizing the components, nothing will happen. I have never seen any of my plant where we need to close the suction and discharge stop valves. How to avoid ammonia leaks? My suggestions: use welded joints instead of flanges. Wherever possible, don't use flanges. So chances of this 22% flanges leaking are deleted. Use proper material for pipes, vessels, a very, very important point. I did a lot of projects in Porbandar and these areas, and you will be surprised that people there for ammonia plants, they were using GI pipes for ammonia. So I said, what is this? Why are you using GI pipe? He said, GI pipes are thicker than the steel pipes, so we use it. But they don't realize that it is not at all suitable. All that galvanizing will go into the compressor because it is galvanized from both sides, and there will be this pipe is not at all suitable. It took me nearly 2 months to convince my customer that I will not do your job if you insist for GI pipes. So this use of correct material for vessels 70-80% plants, at various places, they use this scrap material from shipyards, steel plates and all that. That is totally wrong. Those plants can create a lot of accidents like bursting, etc. Correct location and orientation of valves is important. All liquid line valves, just remember, I'm telling a very important point, should be with horizontal stem. That is, stem should be facing towards your chest and not top, vertical top. Because if you have a vertical wall in a liquid line, there will be liquid which will be trapped before the valve when valve is even open. All these things we have given in our manual. Avoid liquid ammonia traps. Use very important, not ordinary stop valve. Use quick drain stop valve for oil draining. What is a quick drain stop valve? That when you, by mistake, if you release your hand, the valve will close automatically. You don't have to. Many times accidents have taken place because the operator has opened the ammonia valve quickly and lot of liquid has come out. He has ran away and the ammonia has been leaking in the plant. So this is important. Use dual safety valves. So if one valve is operated, you don't have to stop the plant. You can use a dual safety valve. So the second valve, safety valve can come into operation. To avoid leaks from side glass, use auto-closing valves at the inlet and outlet and a shielded side glass so that even if it breaks, the auto-closing valves will close the ammonia supply to the side glass and no much danger will take place. Now, when we install a plant, the first biggest mistake we do is we order valves and walls are ordered in quantity कि 4 इंच का 8 वाल भेज देना 2 इंच का 6 वाल भेज देना अरे but you don't know where this wall is going in your plant. If it is an insulated line, if it is going on the suction line, then 90%, 70% plants have seen that to reach the handle, people have to cut the insulation and then only the handle is visible. So long stem walls should be used for insulated lines. A very, very important point to be kept in mind. Now we are going to discuss build confidence to gain competence, training and framing human mindset of operating the plant and promote continued energy saving techniques. This energy saving we have discussed a lot in our earlier 6 seminars. The standards which need to be referred for ammonia is ammonia safety standard, which is AAR1 currently. Shortly it is getting converted into BIS government standard. This standard also we have contributed a lot, our committee. Standard ANSI IIR2, this is Special Institute of Ammonia Refrigeration in USA, approved by American National Standard Institute, is a safety standard which is available. Then ASHRAE 15 standard is a safety standard. For piping, ASME B31.5 2013 or the latest, that refrigerant piping is very important standard. Pressure vessel code ASME section 8 is important. TEMA standard is Tubular Exchanger Manufacturers Association, is for the heat exchanger manufacture like condensers, chillers, etc. ISO 5149 is a safety standard. EN 378 is again a safety standard. And OSHA is the American standard, Occupational Safety and Health Administration standard. This is important standard. Now let us start with part 1. We will go part 1, part 2, part 3 and part 4. Part 1 is understand the working of the refrigeration system. See, every place has a different ambient conditions and the plant should be designed to suit the ambient conditions. Suppose that means if you are designing a plant in Simla and if you are designing a plant in Delhi or Rajasthan, there will be different design aspects. pH diagram of the system installed has to be available and understood. Understanding of pressure. I have already mentioned that the person who knows pH diagram well is 95% excellent engineer. Study the PS diagram. Every time you study the diagram, something new will occur to your mind. Select energy efficient equipment. Heat exchangers, process vessel should be always obtained from approved and appropriate suppliers. A very, very important point. This is the mistake 90% plant owners do that. They take these heat exchangers or pressure vessels from a designer, they take a drawing and get it fabricated at site or some second grade workshop who do not have the ability to make pressure vessel fabrication. So fabrication of pressure vessels, heat exchangers is very, very important and should be done with appropriate and approved suppliers. Follow correct manufacturing design standards and correct selection of material. As I already told you, don't use uh, non-standard material for pipes, for pressure vessels, for everything. Then quality installation, inspection, and regular routine maintenance. Very, very important to see whether our parameters are as per the design or they are deviating from the design. Energy audit to ensure high efficiency is maintained throughout is very, very essential. Design and manufacture of pressure vessels. Now, this is a very, very important. This, as I mentioned, for every city has different temperatures. The latest guidelines, EN and ISO guidelines, say that 17 degrees above water cooled systems, whatever is your ambient temperature, wet bulb temperature, and if it is a water cooled system, add 17 degrees into that. For example, if 29 degrees is the wet bulb temperature, 43 degrees centigrade should be design temperature. 17 degrees above dry bulb for air cooled application. If your ambient is 40 degrees centigrade, 42 degrees centigrade, then design pressures should be 57, 58 degrees centigrade. Our AAR standard, we have taken 21 kg per centimeter square to suit Indian condition. AAR standard is for Indian conditions and 27 kg for air cooled application. These pressures are different than ASHRAE or IIR standard. They indicate much lesser pressures, 20 kg for discharge and 15 kg or 17 kg for low side, etc., etc. That is not acceptable in India. Our pressures are much higher. Then most an important point, people design low side of the system and high side of the system for different pressures. My suggestion is I personally what I do, I design both high side receiver and low side vessels for the same pressures. It doesn't cost more. Instead of 12 thickness plate or instead of 14, you may have to use next size of 16 But it reduces the sizes of the vessels considerably because then you don't have to pump down every time you stop the plant or develop a problem in the system. Ammonia then can be stored in low side LP vessel without pumping it down. So my plants, I always design that. The most important vessel in any ammonia refusion plant is ammonia receiver because it stores the entire quantity of ammonia in a system. And many times a standby is essential or recommended because in case of problems with the main plant, you should be able to pump down ammonia somewhere in the system instead of releasing it to atmosphere. Normally, this is what we suggest. Provide a standby receiver or two of 50% or three receivers, two of 50% and one 50% standby. Depends upon the criticality of the plant, but you can design according to that. The next very important design precautions, that is pressure vessels. Use always boiler quality plate. Since this plate is not readily available from SAIL, Steel Authority of India, IS 2002, lot of people use 2062, which is a structural steel and it is not a boiler quality plate. Its carbon content is very high and it can lead to cracking of the vessels. So IS 2002 grade 2A or SA 515 or 516 grade 70 plates should be used for receiver fabrication, condenser shell fabrication, chiller shell fabrication, etc. Use proper thickness as per TEMA standard, TEMA Tubular Exchangers Manufacturers Association. Consider joint efficiency if you are not as zero point 0.7 if you are not doing no radiography. Add a corrosion allowance of 1.6 mm in calculated thickness and then provide the vehicle thickness. Fabrication as per IS 2825 or SME Section 8 Division 1. This is important. The next is use backing strips for shell and end plate. Lot of places I have seen the failures taking place because dish end diameter and the shell diameter, shell is rolled and dish end is purchased from someone else and they don't match. And to fill up the gap, people who use welding, additional welding. Now welding material is not as strong as steel plates and lot of places leakages or accidents have taken place because of the shell and dish end getting separated. Use minimum shell sections. I've seen many places receivers, shell and tube condensers. There are 3, 3, 4, 4, 5 joints on a 20 feet long receiver. There are 4 pieces or 5 pieces. Why do that? Use single plate or at the most one joint if the receiver is too long. So very important point. Do not use valve below a safety valve. This is another issue. 70, 80, 90, more than 90% people use valve. And when I ask them why are you using valve, because then they say that साहब वो safety valve leak होता है. So use proper safety valve, calibrate it, and don't use stop valve below safety valve. If you want to use it, some people insist, some customer insist for a stop valve, then keep the valve fully open, remove the handle, and the handle should be kept somewhere under lock and key, much away, so that operator does not fiddle with the handle. use dual safety valves. Side glass should be with check valves and with sensors preferred. This is a backing strip, how the joint of shell and end plate should be made. And many times if the vessels are small, post-weld heat treatment is also recommended. Many consultants like EIL, Uday, Power Gas, they insist for the post-weld heat treatment. Just for the sake of ease of your use, I have calculated the thicknesses using 516 grade material, and these calculations are there in our AR standard. For 24 inch, 30 inch, 36 inch, 48 inch, what thickness one should use. I have seen people using very thick materials unnecessarily. They use 16 mm, 18 mm, 20 mm plates for a very small diameter. And when I ask them, they say, no, we want the vessel to be very safe, which is wrong, which is wasting our country's national resources. Don't over you thick the material. These thicknesses are more than enough. And the dish end is normally one size higher material because people don't use this these types of descents, which are formed descents, they use this by pressing, and when you press it on the knuckle radius, the thickness comes down. To compensate that, they use one size thicker. But if you get a spun descent, then it is not necessary. You can do these calculations and you can reconfirm my opinions. The pressure vessels should be tested in the factory 1.5 times the hydraulic pressure, the design pressure, and the factory 1.25 times design pressure for leak test at site, and periodic thickness testing of receiver, checking calibration of safety valves once in a year. The thickness can be checked not by removing the ammonia. Externally, it can be checked. There are thickness sensors now available, and it will show you where the thicknesses have gone down below the design values. In that case, you have to replace the vessel uh, with a new one. So this is required. The next, this is the ammonia manual, suggested installation, operation, maintenance practices for closed circuit field directed ammonia systems. My suggestion, if you are working on ammonia plant, follow this, and I can guarantee you that there will be no accident in your plant. I've done more than 3, 4, 500 plants. All my plants are safe. I haven't come across accident in any of my ammonia plant. So now, before we go to the part 2, I would hand over back to organizers because they want to show something about RefCode, which is going to be an important event. Anish, please kindly take over and from me and show your slides. Okay, thank you.
Thank you, sir. Yeah, we'll come back to you.
Yeah.
Ravi,
Yes, sir.
yeah, and is Mr. Rohan available?
Mr. Rohan.
Yeah. Okay. Well,
Are
you
you?
can play.
Yes. I'm going to play the video first.
Yeah, for the benefit of the viewers, this time RefCode will be organized on a virtual platform, and we will be now playing you a short video on how it is. So we request all of you to log in and see how the first exhibition, virtual exhibition will be like. So yeah, Ravi, please show the video. Rohan.
Good evening, Anish.
Yeah, good evening, Rohan.
Yeah.
So, would you like to share?
Yeah, if you could just give me the share screen option, yeah, show my screen. So is the PPT visible to all?
Yeah, sure,
Yeah.
sure.
Okay. Good evening, everybody. Thank you so much for joining for this webinar. I hope Mr. Paranjpai, and we all know that Mr. Paranjpai is a very, I mean, like very good speaker, and the kind of information he always shares is always, very useful to all. So again, thank you all. I quickly just take you to what exactly the RefCold Virtual Expo is all about. So basically, this year ISHRE and Nuremberg decide that, okay, let's not do a physical exhibition, let's go a virtual. So this will be the first ever virtual exhibition on cold chain and refrigeration industry. We are very thankful and we are very proud to say that within two editions only, RefCold India has become the South Asia's largest exhibition on cold chain, industrial refrigeration and reefer transportation. And again, we would like to thank you, the whole industry, for their continuous support to us. Now, RefCold has become India's international platform for refrigeration and cold chain industry. Last year in Hyderabad, we not only have the exhibitors, but we had visitors also from across the globe, such as Bangladesh, Sri Lanka, Europe, and UAE. Like this webinar in RefCold, we always have these workshops and seminars where we try to give knowledge to the end users. And during our virtual exhibition as well, we are going to have live sessions with the industry experts like Mr. Manjunath, Mr. Ramesh Paranjpe, and everybody else. They'll be talking about the new latest trends and technologies in the refrigeration industry. Along with that, we are also planning to do a virtual business summit, that is B2B meeting for exhibitors and visitors to facilitate their businesses. So now most of you have this, okay, you all have visited the physical exhibition. So there's the booth and everything is there. So a lot of people have this thing in mind that how a booth in a virtual exhibition will look like, how I can showcase my product, how I can showcase my company video and all that. So this is how a typical virtual booth will look like. Now you can see here there are different screens. On the top screen you can always have company name, the fascia name is there. In all these screens, in one screen you can play a corporate video, on another screen you can play a product profile, and you can upload the different images about your product. What we've also done is that we have created several different packages for a company to choose from to participate in RefCold Expo. These are some of the packages. You can see all the deliverables of a particular package. You can live chat with the attendee, you can video chat. Suppose you as a visitor or an exhibitor join RefCold, so you can have you think that, okay, this person, this can be useful, you can directly speak to him, you can have a live chat, you can have a video chat, and all these things are there in the virtual exhibition. So I'll just quickly go through all the packages. We have different packages for company to choose from. This is how the another platinum package will look like. Some of the benefits. This is again the gold package. Silver package. We have the basic package which starts from 35,000 plus taxes. That's it. But if you are a visitor, then you can obviously log in for free. It's a 3-day exhibition where you can log in for free to visit the exhibition. There will be companies who will be displaying their products and everything else. So you can log in at www.refcoldindia.com. The exhibition is from 29th of October to 31st of October from 9 a.m. to 9 p.m. It's 12 hours because we have international guests or visitors also, so we have kept the timing in such way. But I would like you all to register there and be a part of RefCold India virtual exhibition, the first ever virtual exhibition on cold chain and refrigeration industry. Thank you so much. Thank you, Anish.
Thank
you so much for giving us the time.
Yeah. Thank you. It was quite a good presentation, and we all look forward to the first virtual exposition. Thank you, Rohan.
Thank you
So
so
we'll
much.
go back to Mr. Paransper. Ravi, please share the screen.
Okay. Okay. You can see the screen now.
Yes, sir. We can see, but it's not in the presentation form. You'll have to go. Yeah.
Now we go to part two. Part one we have covered, which is a design aspect. Now plan part two is how to construct a machine room, because when we are building a safe plant, we don't have to build only a refrigeration plant. We have to see that everything is safe. The plan proper layout, enough maintenance space. I have seen in Mumbai and some areas, the compressors are so near to each other that you have to literally step over the compressor to reach the second compressor. So for operators, it is very, very difficult. These proper distances are not maintained for maintenance. Taking out any item from machine room becomes a big problem. I will give you a very interesting story here. We constructed for Hindustan Shipyard the air conditioning plants. In those days, long back, about 40 years back, when I was in Kirloskar, we used our reciprocating compressors for air conditioning, KC6 compressors, KC4 compressors, like that. And on the ship, the main area is main engine, and compressor room is at the side of the engine room. So once engine is lowered inside the ship, nothing can be taken out from the ship. And unfortunately, our compressor had a breakdown, and we wanted to remove the compressor. There was no space for removal. Nobody would remove the main engine just because our compressor replacement. So you will be very interesting story. You will be knowing we had to ultimately cut open the ship from externally, from the visible side, and take out the compressor from there, and then reweld the ship. Can you imagine? So enough maintenance spaces should be available. Proper plant room ventilation should be available. There should not be overheating of any equipment. In case of problems, accidents don't take place by planned manner. They are accidents. So doors should be available for quick evacuation. Otherwise, people get trapped inside and deaths can occur. Plan cable trenches, oil trenches, water trenches very well. Install anti-skid flooring so that nobody slips on the oil or on the water. Very important. Safety equipment should be kept in the plant room that we will discuss later on. First aid kits should be available in the machine room, easily accessible. And in case of emergency, an emergency stop button, which is visible to everyone, should be readily available so that just by pressing the stop button, the entire plant can be stopped. So this is how the machine room should be planned. The third part is there is a more detailed machine room planning in our book, AAR book, which I mentioned. What are the other precautions? Your clothes, your dresses should not be hanging in the machine room. You should not take lunch into the machine room. And so many issues. These always happen. In any plant I have seen, these things go on happening. So again, I am repeating, it is an attitude. Every operator, every person working in a machine room should ensure that whatever he is doing is safe. And not only that, he should not say that I am doing everything safe, but my assistant or my colleague who is doing something wrong, I cannot tell him because he will get angry, which is incorrect. You should have a good relationship with everyone. You should discuss, tell him कि बाबा ये ऐसा मत करो, इसमें ये problem हो सकता है. MCC to have proper forced ventilation. MCC gets very much heated because there are all contactors inside and all terminals, and there's MCC should have a ventilation. Otherwise, there will be overheating and can catch fire. Provide energy meter to record entire power consumption of the refrigeration system. This I have rarely seen in any refrigeration plant. If I ask operators, they said compressor इतना एम्पियर लेता है, फैन इतना एम्पियर लेता है, पंप इतना. अरे बाबा टोटल पावर आपको कितना लगता है? वो नहीं साहब, हमारे पास 100 मीटर नहीं है. So total energy meter is very, very important. Every day you should be able to record that my today's production was so much and I have consumed so much energy. Then only it will give you guidelines that where the mistakes are taking place, why your power consumption is going up. Enough distance between the compressors and the motor control center, MCC, should be available. MCC should not be very, very close to compressor because compressors get overheated. Always provide cable trays and entries from the top of the panels. This is preferred so that these are visible to you. Don't run this through the trenches. If you run it through the trenches, they will be flooded with water. They will be full of dirt and dust. They can be even eaten up by the rodents like mice, and you will not know till the accident takes place. So your wiring, piping, these should be, electricals should be visible. So always take the electricals from the top. Proper earthing is very, very essential. Lot of places we get complaints. His quality of solenoid valves is not good. They are constantly, coils are burning. This is happening. Imported में होता नहीं है. I said imported लगा के देखो. उसके बाद उसमें भी होना चालू हो गया. Then I said your earthing is not proper. Your earthing is faulty. Do proper earthing and these problems will be overcome. So proper earthing for electronic items, electrical items, PLCs is very, very important. Cable trenches to be designed so that no water accumulates. Fire protection devices very near to the panels are essential in case of electrical problems. Electronic items through UPS and protections should be against surge, high voltage, earthing faults, etc. So these are the electrical issues. Compressor panel to receive supply after all the safeties are satisfied. A very, very important issue. I will tell you a very big accident took place in Pune. I will not name the client, but what he had done, वो HP कटआउट कॉन्स्टेंटली ट्रिप होता है, इसलिए उन्होंने HP कटआउट बाईपास किया था, and the plant was operated with the result that big pressures built up in the system. There was no protection and the big accident took place. Such a big accident that even the building collapsed. So very, very important that unless all the safeties in the system are not bypassed and then the green light lights up that all safeties are operating, then only the compressor should be started. This is very important. Don't bypass any of the safeties. Go to the root cause why the safety is cut out, either discharge temperature cut out, LP cut out, HP cut out, oil pressure cut out, they are tripping. And remove the problem, don't bypass them. Emergency stop button, I already told you, outside the machine room, inside the machine room is essential. And provide an electrical, in addition to PNID diagram, display it inside the machine room so that operator is able to trace the wire, which wire is going where, and he is able to locate if some bulb or some red lamp comes on, what is causing that. So electrical wiring diagrams and piping and instrumentation diagram should be displayed in a machine room. That is very, very important suggestion. This is emergency electrical trip switch. It has a glass and a spring loaded knob. So what happens when you break the glass, because the spring brings the knob out and the entire electrical circuitry is disconnected. So these are emergency uh, electrical trip switches. When the box door is closed, because of the pressure of the box door, the handle remains pressed and the circuit is on. The moment you break the glass, the circuit is off. This is very important switch. Extra wiring, lot of extra wiring if you are having, just remove it. Don't keep bundles of wiring inside your panel, below the panel. You won't be able to trace out your wires. So very, very important, provide just adequate wiring for the panels. We go to the next very, very important part, which is piping and installation. Most important part in a field directed system. In Freon plants, it does not happen because most of the systems are built by the recognized manufacturers inside their plant. Last time I had shown you the advances in ammonia refrigeration systems. Nowadays in Europe and in USA, they are building factory made packages using shell and plate heat exchangers or plate heat exchangers and with air-cooled condensers, like I showed you, Star Refrigeration UK, etc. If you remember, all my presentations are available on your website and have been also circulated to all those people who are attending it. So you will have this full information available. So don't use piping like this. If you enter a new plant room, I have seen many times people call me and they say, "साहब हमारे plant में problem है, आप जरा देख लेना." When I go there, I have to trace out which pipe goes out where because there is so much jumbling of piping. And I ask them, "Why did you do that?" They say, "इधर से भी bypass दिया है, ये नहीं चलेगा तो यो चलेगा, वो नहीं चलेगा तो वो चलेगा." So which is a very wrong practice. Don't jumble up the piping. Don't do piping like this right angle bends. This is a wrong piping. And just now I'm facing a problem in one of the installation where this type of piping has been done for the float switches. Now we have to change. The float switches are not operating because they are showing the pressure drops in these lines are indicating different operating conditions for the float switches and for the vessels. So do the simple piping. The next slide shows what piping material and thicknesses to be used. Use piping and fittings as per NSI B 31.5 2013 or latest edition. Carbon steel A53 grade A or B ERW pipes or A106 grade B, AB seamless pipes or for low temperature A333 pipes. These are the correct grades of pipes. Do not use galvanized piping. I have already given you an example what people do. Then for 1.5 inch and smaller, use schedule 80 size pipe, 2 to 6 inch schedule 40, 8 to 12 inch schedule 20, and above that schedule 80 is thicker than schedule 40 and schedule 40 is thicker than schedule 20. All weld fittings, I have already told you, avoid threads or avoid flange joints to avoid the leakages. I have told you that it is sometimes it is not possible to reach the controls in air coolers, in cold storages, especially in minus 20 degrees rooms, because operators will hesitate to operate any control at that temperature, and welding and other things are not possible. So my suggestion, except the air cooler, as we discussed last time, keep everything outside. All controls should be available outside the uh, air cooler wall, and they should be easily operable for maintenance and for adjustments. So this is the good practice. I have shown you this photograph, how to do the piping. There is a walkway on which you can walk and adjust your piping. This is an very important suggestion. Avoid locked up liquid refrigerant. Liquid refrigerant is not compressible or expandable. And what happens? You have a non-return valve. Here there is a solenoid valve. If the solenoid valve closes, the liquid will get trapped because it cannot return back. And this liquid, if the ambient temperature goes up, your pipeline will burst. This liquid is trapped, and when temperature increases, its pressure will increase, and the pipeline will burst. So very important, either provide a safety valve on the liquid lines or do the piping in this manner: solenoid valve and then your NRV, so that NRV is always open. Even if your solenoid valve is closed, liquid ammonia will not get trapped. This is one of the major reasons of accidents. Then don't provide loops into the liquid line. I have seen many places in wet return line, especially from LP vessel back to compressor, the piping is with several loops. Loops can cause big problems: liquid hammer, liquid trap, and big problem. I will explain you in your next slide what happens. Very important slide. Hydraulic shocks. Lot of people complain, 80% people complain that when they use pump circulation systems, there are heavy vibrations in their plant. Why this happens? Because the pipe is flowing, which has liquid plus ammonia gas, and the gas density being lower, it closes the pipe, and when the pipe gets closed, the gas gets trapped. Ammonia gas void has taken place. If you see in this second slide, uh, sorry, uh, uh, in this slide, if you see second B atom, the gas is trapped. Now this gas rapidly condenses because the temperatures minus 40 degrees, minus 20 degrees, and then the liquid hammer takes place on the end cap. Because the liquid is trapped here, liquid impacts the end cap because there is no space, and this results into a very big failure. In one of my plants this has happened, uh, because the person had put a valve in LP line, and that valve was closed, and it created a problem. A schedule 80 thickness A106 grade B pipe, and that is wet return line. You can see how the end cap gets broken and the entire ammonia leaked because of the this hydraulic hammer. So very important point. This is the photograph of the same. You can see the how the end cap has totally collapsed, even if the correct pipe has been used. So very important how to design plant with wet return and ammonia lines. The next, welding practices. Lot of people use maybe correct steel for the piping and for the shell, But doing correct welding is very, very important. The root run should be done with TIG welding, that is tungsten inert gas welding, because then your contamination will not enter into the pipeline and your internals will remain clean. Root run with TIG, or that is argon, or with MIG uh, gas for vessels. Welding by qualified welder, certified welder, not by any welder. Very, very important. Certification, qualification is very, very important. Don't use welding as a window welding or as a residential welder. Welding rods, argon, high side AWS and on low side E7018. Very, very important. This is D&H Session. Don't use structural welding rods 6013. They will not withstand. Your vessels will fail after certain years. Remove all internals, controls, strainers, solenoid coils before you do welding. Otherwise, welding is a very high temperature process and your internals or strainers, coils will get damaged. So this is an important issue. The next slide, piping color code, very important. HP gas, hot gas pipe, booster gas, receiver to economizer, what colors to be provided. Economizer, I have given the colors. I will not read this. You can see these colors: red, green, purple, black, etc. And then your identification of piping becomes easier. So look at this. This is a good piping. The ammonia discharge, red color with arrows and a sticker showing ammonia. The suction line green showing again the direction of flow on the compressor side. So this is compressor suction discharge line pipe. All pipelines, high temperature refrigerant liquid, high temperature refrigerant gas suction, medium temperature, all these stickers should be on the pipeline, and then it becomes easier, and the flow direction should also be indicated. This helps the operators very well in maintaining their plants well. This is a summary. This will be available to you on your website. I will not go into the more details of reading this, but this slide will be available to you. The next is controls. Controls are two types, part 5, operating controls and safety controls. Both controls are important, and try to minimize welding joints. For example, this is a liquid line in a pump circulation system. See how many controls we use. Two stop valves, inlet outlet, further then the strainer in between, then the solenoid valve, and then the non-return valve. So in all there are how many welding joints? 2, 4, 6, 8, 10, 11 welding joints, 12 welding joints. Instead of that, now latest technology has controls which has everything built into a compact one piece. So only 2 welding joints are required. Lesser the welding joints, lesser is the chances of leaks. And not only that, your weight of the pipe comes down drastically. For example, in drawing, this pipe shows very light, the top pipe, but you can't lift this. It has to be lifted by crane. It is a very heavy pipe. So if you fabricate it on the ground and try to fix it, you will have to lift it with the crane. This is my experience. Use composite walls like this. This is a composite wall, and everything is, the pressure drops are low, welding joints are low, everything is useful. Then for oil draining, I did mention to you, use quick drain closing valve. This is a quick drain closing valve. It is a spring loaded with a handle. So when you keep the handle pressed, the valve is open. When you, by accident, if you lot of liquid is coming and if you want to stop, just release your hand, the supply ammonia removal, oil removal will be stopped. So this is quick closing oil drain valve is very, very important. It has a stop valve also behind that. The next slide, I'll show you a stop valve behind this quick closing valve. So you can keep it open or close it when you are wanting to drain the oil, then only open it. This is a dual safety valve, very, very important dual safety valve for the all the pressure vessels, ammonia receiver, LP vessel, accumulator, interstage cooler, etc., etc., oil pot. Some vessels require dual safety valve, some vessels require single safety valve. Small vessels require single safety valve, but receivers, LP vessels will require a dual safety valve. How dual safety valve functions? You can see the stem. The stem, the one valve which is on the right hand side is in operation. The stem has closed the left valve. Suppose this valve blows off because of the high pressure, then you can take the stem back. This valve which has operated will close and the second valve will come into operation. So you don't have to remove ammonia from your system. You can continue to operate the plant without any interruption if you use dual safety valves. There are safety, this you do not know whether the safety valve is operated or not. So there are indicators now available. If the safety valve blows off, the indicator will go to the right hand side indicating that this safety valve is operated. These are available in India also now. Or people provide these rupture discs. These rupture discs are also important. Many people provide that with a pressure gauge. So if the safety valve is blown off, the pressure on that line will be always high because it will be discharge pressure. And then you will know that this safety valve is blown off, and then you can put second safety valve into operation. These dual safety valve with rupture disc and ammonia sensor. Some people put ammonia sensors also, very critical plant, at the outlet, and that ammonia sensor will give alarm indicating that the safety valve has blown off. Otherwise, many times during night time there is no operator and some accident has taken place, people do not know about it. So this is important. This is setting of safety valve is very, very important. People do not know how to set the safety valve, at what pressure it's to be set. For example, if your liquid receiver, normally it is designed for 38 degrees centigrade ambient, 200 psig is operating pressure, and the safety valve is set at 300 psig. Uh, the safety valve starts seeping at 270 psig. Operating pressure is 200. 300 is the design pressure of the pressure vessel. 330 is the relief pressure, fully open. The safety valve is fully open. And your test pressure is 396 degrees. This is for the high side. Similarly, I have indicated the pressures, set pressures for the low side at minus 40. You can calculate for minus 20 according to the same chart. This chart will be available to all of you. Always, I had mentioned last time, the safety valve outlet discharge point should be outside the machine room, 15 feet above the maximum occupied height of the building. So ammonia, even if safety valve blows, it will go to the atmosphere and it will not cause any harm to persons who have occupied the buildings. This is the way the safety valve outlets are shown with a cover on the top. so that no dirt, dust falls inside, or with a U bend, so that again same purpose. The next slide shows, I just now saw one installation just about 6 months back in Mumbai. What they have done, they have used dual safety valve, everything okay, but in order that it should not go to the occupied area, instead of taking it 15 feet high, he has taken the pipe down into the machine room. The whole purpose of safety valve is defeated, because if it blows off, entire ammonia will go into the at the bottom at the occupied area. So this is totally incorrect piping, and his logic was totally incorrect. We had to modify this. These are the pressure switches. Use all these pressure switches, KP switches, HP, LP, OP for intermediate pressure, for two-stage compressor, intermediate pressure switch. These are all important pressure switches. Don't bypass them. They are all safety switches. For high discharge temperature on the compressor side, use this. I use it in my plants and it helps a lot. If the compressor temperature, discharge temperature is going up because of any reason like valve plate breakage or any other reason, or discharge pressure going up and temperature going up, the temperature switch will trip the compressor and protect your compressor instead of creating problem. So temperature switch, high discharge temperature switch for mineral oils around 130 degrees centigrade is good enough. These are the pressure transmitters. These are for automatic plants. You can use pressure transmitters. They will give 4 to 20 milliamp signal output, and then you can put it into your control panel, whichever SCADA system or whichever PLC panels you are using in your plant. Leak detectors, very, very important. Leak detectors should be in the plant room. One detector alarm should activate at normal ventilation at 35, because I had mentioned last time that 25 ppm can be detected easily by any human being by nose because of the smell. The second detector, emergency ventilation, should be activated at 1000 ppm, and fan should discharge air up vertically with minimum discharge velocity of 250 fpm per minute. Or this is important, how to select the fan. These are the set points of the sensors, various set points. I will not read out. Air outlet, negative pressure. Many times, if it is a totally closed plant room, many people prefer negative pressures in the machine room, because then chance of ammonia leaking outside the machine rooms are nil. It's an expensive process to build a machine room with negative pressures, but that is possible. These are the ammonia leak detectors. This is centralized computer control system. You can see on the control panel, it is the entire PNID has been printed. Air coolers, pressure vessels, compressors, intermediate vessels, etc. And then you can read any temperature, any pressure, or record it from these panels. These are very advanced panels and they should be used wherever possible. Very important, many people provide ammonia dump tank. I did mention to you, some accidents take place because you do not know where to remove the ammonia. So many customers provide this ammonia absorption dump tank. This was earlier suggested by Association of Ammonia Refrigeration, and this is the design of a dump tank. I'm purposely giving the full details of ammonia dump tank, and if you see this vent line from relief valve or from any place can come into this tank, and the tank is full of water. So ammonia will be absorbed in water. It's a big amount can be absorbed, nothing will happen. And these dump tanks are very useful many times. I've given the length, height, width, how many gallons of water, and for what capacity of refrigeration it is useful. So this information may be useful for many people. This is another design of ammonia dump tank. Now ventilation requirements, normal ventilation, this is normal ventilation, emergency ventilation, one air change per 2 minutes. Ammonia concentration never to exceed 40,000 ppm. This is very, very important because 25% is the flammability limit, 16% and 25% maximum, which is 40,000 ppm. So this should never be exceeded. Otherwise, there is a chances of flammability also. So ANSI ASHRAE 15 ventilation air quantity indicates the quantity of air to be provided. This is what happens when ammonia leaks. A white cloud is formed in the machine room or outside because atmosphere has moisture content and the ammonia easily gets absorbed into the moisture, and a white cloud, which is a normal in winter, in monsoon what we can see, similar clouds are seen when ammonia starts leaking. This is see, this is ammonia can be detected with smell. This accident has taken place. Police have entered, but everyone is close, holding their nose because the ammonia smell is coming everywhere. So this is an accident which has taken place. See this accident, the discharge pressure cutout, which I mentioned in a plant was bypassed. The water flow to the condenser was choked because of the filter. There was no water flowing through the shell and tube condenser, and the pressures rose beyond design pressure limits, and the entire plant burst. This happened in Pune. I will not name the customer, but the accident was so severe that not only the refrigeration equipment collapsed, but even the entire building collapsed because of such a high pressure wave developed inside the machine room. So don't bypass any controls. This is the damage taken place because of use of incorrect material, IS-226 material, high carbon content material. It will crack. It is a stress corrosion cracking, what they call, and because of use of non-correct material. Precautions for safe operation, do's and don'ts. Don't allow any contamination in the system. In an open system, you can always change the oil and remove the contaminants, like as we do in our car. Brand new car, when you purchase, they say change the oil after so many hours. It cannot be done in a system, in a closed system. Whatever remains in the system till the breakdown takes place, it remains in the system. So ensure that there are no contaminants inside the system because it is a closed system. These are the only refrigerant and oil. These are the two only good things in any system. Don't have any contaminants into the system. That's why I suggested TIG welding, MIG welding for pipelines, cleaning of pipelines before they are installed because they are lying in the dust for a very long time, and all that dust can go inside the machines if you don't clean them. So this contamination, heat and time is a deadly trio. The last part, use proper grade anhydrous ammonia refrigerant. There should not be water. refrigerant and oil less than 0.2% to avoid stress corrosion. Remove water. There are water rectifiers available. Use synthetic oils for low temperatures below minus 20 degrees centigrade so that your discharge temperature is within limit, and these synthetic oils can withstand much higher temperature than mineral oils, like up to say 170, 180 degrees centigrade. These are the contaminants. You see on the wall sheet, entire wall sheet has started leaking because all contaminants are on the wall sheet, accumulated on the wall sheet. These are all contaminants. So clean the system before installation. This hot gas defrost strainer, because of the heat, it has gone totally damaged because the pressures and temperatures for the defrost are not properly maintained. Maintain a low pressure for defrosting, not more than 6 kg, 7 kg maximum. Don't allow full discharge pressure for hot gas defrost. This is a pipeline, insulated pipeline. You will see this is a regular pipeline. The insulation has been made. A pipe which is visible to naked eye, yes, you can replace it, but insulated pipes cannot, you do not know what has happened inside. The moisture has seeped in and the breakdown, the accident has taken place because of improper insulation. Improper, as I mentioned, not using long step valves. You can see the valve, which is a very small valve, and the accident has taken place. Total pipe is internally rusted. So very important that how to do the proper insulation, proper pipe, proper anti-rust painting of the piping, etc., etc. This is an installation, use of compressor motor frame by the manufacturer, and the alignment issues then get deleted. Your shaft steel leakage problems will be eliminated, and you will have a very vibration free installation. You can see that this is an operating compressor. You can keep a coin on a reciprocating compressor. It is not falling down. On the cylinder head also, this is a compressor in operation. So very important how you provide the base frames and how do you align your compressors. While lifting, very important, lift the packages very correctly. The machinery, inside machinery is expensive. Don't lift the machinery uh, at random with any atom. There will be markings on the machines. There will be markings on the, your anti-rust paint will go away. So lifting is very important. Now look here, this machine looks very well painted, well maintained. But what is the biggest mistake they have done? They have provided a valve below a safety valve, which I have mentioned is not recommended by the standard. But lot of people say the Indian valves start leaking, therefore we need to provide a valve. I won't object to that. If you provide this type of valve, keep it fully open, remove the handle, and that handle should be into plant manager's lockup so that nobody by accidentally closes this valve. Now here I had asked him to use dual safety valve. He has used dual safety valve, but in addition to that, he has used one more valve to bypass both the dual safety valves, which is again very incorrect practice. All these slides I am showing you because these are my experiences, and these have met with a likely to meet with an accidents. So these are the wrong practices what people do. For pumps, provide a tray below so that condensation of pump dripping does not get spread all along the plant room. It collects in the tray. The flooring of the plant room, machine room is important. There is a frost heaving. What happens, this moisture which goes onto the machine room seeps through the cracks, and when the temperature is lowered, the water expands and the floor cracks. To avoid this, provide these ventilation pipes to prevent frost heaving. There are 3-4 methods of providing this anti-heaving solutions like glycol, heating elements, uh, this ventilation pipes, etc. Last time I think we had shown this. This pressure equalizing panel walls are very important. These days the panels are installed very airtight, and when the temperature starts dropping, if you don't have pressure equalizing panels or valves, your entire cold storage will collapse. This is my experience. See, I have more than 50 years experience. Today, I'm sharing my experiences, and why I'm showing these slides, because this is what has happened. The people have not provided the ventilation uh, valves, and the entire cold storage of crores of rupees has collapsed when the temperature started getting down from ambient temperature, because the air volume goes on reducing as the air is cooled, and the delta P is created, which forces the panels to collapse. Don't use damaged materials. Accumulation of cooling tower piping overflowing. This is a regular, I have seen in many places on the terraces, it's full of water. Avoid these practices. Avoid this water accumulation. Avoid this, replace these rusted pipes as quickly as possible. Don't do the oil draining with a plastic pipes. I have seen this is what has been done and causes a lot of accident. This is the oil pot. This is the actual photograph taken. Use proper oil draining procedures, oil drums, and methods. I'm going a little faster now because we are running out of time. Pipe support to allow expansion and contraction. Don't rigidly fix the pipes. If you see on the top of it, there is a hook, and that hook ensures that this pipe can be expanded or contracted. It's not rigidly fixed. Okay. So next slide. This is okay. People keep anything on pipelines with their diaries, their telephones, their pots, uh, clothes are hanging sometimes. So this is, again, I'm going back to my first slide. Always when you are doing something, think about it whether you are doing something wrong. And if you feel that this is wrong, then don't do it. Maintenance, standard operating procedure, energy saving techniques, process hazard analysis, process and implementation diagram schedules, logbook maintenance, indicating design versus actual readings. All these things are important. Maintenance, piping and instrumentation diagram, electrical and control wiring diagram, etc. I will not read this slide further. We have a shortage of time. Safety, use always belt guards for compressors, platforms for the evaporative condensers, then receivers, some protection. To protect the panels, build a concrete wall, otherwise your forklift troughs will damage the panels. All the connections should be taken not from the top, should be taken from the side walls of the evaporative condensers and not from the top, because otherwise drain water or the rain water will not go inside. This is a good machine room, plant room. And this is a docking equipment to protect the doors. Forklifts should not hit. There is a protection for the doors. This is a walkway on the roof so that you don't damage the roof panels. Otherwise, people walk on the panels, which is incorrect. There should be a walkway, should be constructed on the roof. Now, the personal safety equipment, what should be kept in the plant room? Eye wash, because eyes are most dangerous. If the ammonia goes into the oil, eye, you can get blindness. So this spurt bottle is jet spray water is important, because as soon as you spray the water, ammonia will get dissolved and your eyes will be protected. This is an eye wash equipment. These are the safety accessories: gloves, goggles, respirators, etc., face shield, long pants, rubber boots. These are the special industrial boots. This is a torch you should carry. Industrial shoes with a steel toe is important, so that by accident something does not fall on your toe. So there are two things. One is equipment safety, what we saw, and second is personal safety. Now what we are seeing is human being safety. Earlier slides, that receiver, uh, doors, etc., we saw the equipment safety. These are the face masks. These are the ammonia suits. If you are entering a cold room, enter with this suit, which has a breathing apparatus, so that you don't breathe ammonia and fall unconscious. And these are the space-like suits, and these are the very important. When you are entering a cold room, you do not know how much ammonia has leaked. So there should be another person standing next to you outside with a long rope. So, and that rope should be attached to you. So if you don't come out within a prescribed time of 1 minute, 2 minutes, then the another person can pull you out. This is my experience. An accident has taken place in which, why the person has not come out, another person has entered, another person has entered, and there has been accident in a cold storage where 3 persons have died because of the heavy leak of ammonia, and they have entered inside the machine, inside the cold room, without taking proper precautions. So very important, this thing. Get to the root cause. What is the problem? Very important. Don't treat only the symptom. Now, this slide is some of the last slides. You can see this person's roof is leaking. So what he has done, he has kept few buckets to collect the water, and he is standing with an umbrella and he is smiling. So he has not removed the cause, he is working on the symptom. So always go to the root cause and not the symptom. These are the AIR bulletins, good practices. Read as much as possible. Many times I have seen the operation and maintenance manual which we supply with the compressor is in the lockup of a manager, and operator does not know how to operate the plant. In case of problem, then he has to ask his boss, साहब वो जरा manual मुझे दिखाना. It should not be such a case. The manual should be always available with the plant room operator and not with the manager. Many times we have to supply two manuals, because one with the operator, one the manager wants to preserve. He takes pride in preserving the books. Anyway, if you wish to design and operate and maintain your ammonia plant accident-free, AR standard for ammonia system safety practices, read it. Every time you will read it, you will get a lot of suggestions. Follow the guidelines of suggested practices written in our ammonia book. If you do this, you will enjoy immense benefits, trouble-free, efficient, and eco-friendly refrigeration systems that no other refrigeration system is capable of doing, giving you total energy savings and total long life of plant without any problem. All few of my plants, latest plant, every plant you build, you provide something extra. There is a continuous incremental improvement, which is only your experience. Otherwise, that 50 years experience has no meaning. It is 1 year experience 50 times. Try to do something better in your subsequent plant every time. With this, I think I have just come to 9 o'clock, which was the time allotted to me. I will close this, my presentation. This was my most favorite presentation because we have been discussing always the good points of ammonia. We never discussed the problems with the ammonia. Today we have covered that and completed the entire circuit. If you do all these things, you will never have a problem. I have constructed more than 400 ammonia plants, and this is my confidence level with which I am indicating to you. Thank you very much for listening to me, all of you. Thank you very much again for ISHRE HQ committee and all of them who have given me the opportunity. I am always glad to share my knowledge. All this will be available on the website. Read it again and again and see where your plant is having problem, and you will, I promise you, you will have a good future. Thank you very much. I hand over back to the organizers. Take it back, Anish.
Yeah. Thank you very much, sir. I would like to invite Mr. Manjunath. Manjunath, are you
Thanks,
there?
thanks, Anish. And firstly, what a wonderful series we had. All these Fridays, and there were so many people waiting to hear your presentation. Paranspe sir, thank you so much. It was an absolutely wonderful presentation that you gave all through these 6-7 weeks. We were always looking forward to hearing your presentation. What's very interesting is that on each of the slides, the live examples, the examples from your experience that you are giving, those are real great pearls of wisdom for all of us to hear. And one point that I would like to talk about to the people on this particular webinar is that this knowledge that he has given us through all these 6-7 presentations, I think the best way to thank Mr. Paranspe is to use this knowledge wherever and whenever an opportunity presents you. That's the best way to thank him. But more than anything else, today is a wonderful day with so much of knowledge being shared by Paranspe sir. Thank you so much. Over to Anish. I think you can conclude, or you'd like to take some questions. I'm not sure what's the plan like.
No, the cost. Yeah. Thank you, Manjunath. The questions will be sent by the respective uh, delegates who want to have any answers for that. So then, of course, we have the feedback form. I request all of you to provide feedback. And once again, I thank our Mr. Paranjpai for having spared his time and for having provided all the valuable suggestions along with the 7 presentations. For like Manjunath mentioned, each and every slide you were telling us about your experiences, you were sharing it to us, and then it was like we never knew that 7 weeks just like that passed by. So it's really a wonderful presentation, and I would like to thank each one of the participants and again our ISRE HQ team, as as well as my colleague here, Manjunath, and of course, finally, and not lastly, but still again, our speaker, Paranj Pai. We don't know like how to thank. It's been such a wonderful presentation, and it's been liked by one and all. Thank you, sir.
Thank you very
Okay.
much, all of you, and best of luck to everyone. I hope your next plants will be much better if you are constructing similar plants. Thank you. Can we sign off now?
Yeah, yes, sir. So we all look forward for the ref code. As we had mentioned, you'll be getting more information. Do log in and enjoy the show. Thank you, Ravi. We'll
Thank you,
close
sir.
off. Thank you.
Okay.
Okay, bye. Good night.
Good night, sir.
Good night, sir.